Okay, I want to point out, looking at the problem, what I would be doing is saying it must have some relationship to what we've done before. And what's that relationship going to be? What we've done before. But now it's more abstract. So what I do is I took this, I just rewrote it over here. I'm taking the root of it. And what I do is I try to get two terms out of it with the coefficient of 2. Whoops, I didn't mean to do that. So I group the first two, and then this is going to be this over here, minus sign between. I make an assumption that I can do it. So what do? Square both sides. And if you do that, you would get 2x minus 3y minus 2 root x squared minus 3y equals a plus b minus 2 root a b. Then what I do, I equate. I equate this with this and this with this. All right? Let me show you where that's written down. Right over here. All right? Right over there. Here comes the trouble. I really do mean a trouble. One is to get a factorization of AB such that the factors of AB would add up to 2x minus 3y. Well, I'm just going to give it a try, and I put it over here. Maybe I shouldn't write that down because it's already done down there for you. I said, oh, x comes out, and you get x times x minus 3y. The question is, what's the sum of those two factors? Let's write this down. So it's going to be x plus x minus 3y. And what would that give you? That would give you 2x minus 3y. So now I know it. It's these two guys over here. All right? Now, the trouble now, it's very abstract. I'm not saying it's not abstract. I got to figure out which is the A and which is the B because the order matters now. Let me start to erase this over here. All right, so let me point out what the two factors are. The two factors are this guy and this guy. And I got to be honest with you, this is a thinking problem for me. All right, I mean, really mean that. So I'm going to say that by inspection, you could say the A is equal to x and the B is equal to the y. Oh, the x minus 3y. And if you wrote that down, let me put that down for you. That would be equal to, whoops. Well, I did it again. Root x minus the root of x minus 3y. All right? But let's say you said, oh, no, I think it's this instead. I think it's x minus 3y minus the root of x. All right? You could say that. Here's the problem, though, and I really do mean it's a problem. You're thinking about it now, and what I'm going to do is, just to make things a little bit simpler, right, I want to point out that x has to be positive in both cases. Right? And I'm also going to claim that x must be greater than 3y in both cases. Repeat that. X must be greater than or equal to 0 in both cases, and x must be greater than or equal to 3y in both cases. All right? So I'm going to say that both answers are acceptable because both answers produce something. But here's the problem. There's trouble in one of the answers. And the question is, what's trouble? I want to point out, if that's the case, this here would turn out to be negative. And why is that? X minus 3y would be smaller than x. So this answer over here is a no-go. There's only one correct answer. And what's that going to be? Root x minus the root of the quantity x minus 3y. This is the only possible answer. Now granted, I understand this can be confusing to write down, but this one just doesn't bode well. All right? By the way, these conditions need to be met for those students to be real numbers. Thank you.